We use the words mass and weight as if they had the same meaning. We normally don't make any difference when we talk about them, but in fact, they are very different. They represent different physical ideas, physical concepts, and although they are linked, we are going to learn the differences about them in this video. Firstly, we are going to define what is mass. We define mass as the amount of matter in an object, so it's directly related to the number of atoms this object has. We measure mass in the International System in kilograms. One of the most important traits about mass is that it's an intrinsic property of matter, which means that it's the same in any place in the universe, on the Earth, on the Moon, on the Sun, wherever we are. To measure mass, we use scales. In scales, we compare the mass of the object we want to measure with a standard mass. There are different types of scales, like electronic scales, Roman scales, and triple scales, only to mention a few. On the other hand, weight is a measure of the amount of force acting on a mass due to gravity. This word is very important. As it is a force, it is measured in Newton. On the other hand, as it is a force, it has a direction. This direction is, for us, is always downwards. The direction of weight is always downwards. But in reality, the direction of weight is towards the center of the Earth, as we are on Earth. If we were in another planet, it would be towards the center of that other planet. One of the most important differences between weight and mass is that weight is not the same in all places. On the Earth, the weight of an object is bigger than on the Moon, because gravity is stronger on the Earth than it is on the Moon. Weight can be zero if gravity is zero. To measure weight, we don't use scales. We use an spring scale of dynamometer. Let's see how it works. A dynamometer has a spring and it has a scale. When we pull the spring with a force, the dynamometer measures the force here. This is a force of 15 newtons. Notice how the magnitude of the force is bigger as the spring stretches. We are going to use this object to measure weight. So we are going to start with an object of 1 kilogram. When I pull up the dynamometer, I see that 1 kilogram has a weight of 10 newton, more or less. On the other 2 kilograms have a weight of 20 newton, and a 4 kilogram object has a weight of 40 newton. This is a summary of the main differences between mass and weight. You can pause the video now and copy this summary on your notebook or read it carefully. Is there any relationship between weight and mass? Obviously, there is a formula that connects both magnitudes. Weight equals mass times gravity. This formula states that to calculate weight, we need to multiply the mass by the gravity. What is gravity? This G represents the strength of gravity. It's measured in newtons per kilogram or meters per square second. On Earth, this magnitude is 9.8 meters per square second, but on other planets it could be different. Weight and gravity are both vectors, and they are also both of them have the same direction. Let's see how weight is different on Earth and on the Moon. So if we have a 1 kilogram object on the Earth, its weight is more or less 10 newton. But if we go to the Moon, we can check that the weight of the same object is much smaller. It's not even 2 newton. The reason for this is that gravity is weaker on the Moon than it is on the Earth. If we take a 2 kilograms object, its weight on the Moon is more or less 3 kilograms. But on the Earth, its weight would be like 20 newton, a big difference. Let's check a 4 kilograms object. It has a weight of 40 newton on the Earth, as we saw earlier when we learned about the spring scale. But on the Moon, it has only a weight of 6 newton. I hope that this video helped you to understand the difference between weight and mass. Now is your turn. You have to complete the activity that you have in the virtual classroom. Bye!